Hello everyone, welcome to the channel. My name is Ravi. Today we are going to discuss about previous topic about importance of the indexes. Okay, so index, as we discussed on previous, I just quickly recap what we discussed. So index being used for SQL query, which make query run faster and access the data will be faster. That's the use of indexes. And there are two type of indexes. One is a cluster index, second is a non-cluster, is a majorly defined of indexes. There are many types, more than 8 types. We are not going to deeper because it's not being asked. So I'm just covering two majorly asked question on the indexes: cluster index and non-cluster indexes. Okay, so cluster indexes is define in itself in table. Once we create a primary key, by default, that table data gets sorted in particular manner and retrieval of the data will be faster. So let me cover that part. Let me go to the SSMS. Let me recollect what we have in previous session. So we have index in this. I have a cluster index and non-cluster in both, right? So let me open that definition of the table. Okay, so in employee table, I have one index and we have defined a primary key. Because of that, by default, it created indexes and constant, right? You can see the constant is primary key. Everyone have same name. So this is a property of cluster index. So let me run the query and see how much time it will take and how it runs, right? So if you see the property of this cluster index, it work as a cluster index seek, right? It is sorted in SQL engine knows how it got sorted, and number of read execution is one. You can see in the property estimated number of rows to be read means because of index help, the query run only once and it hit the output, right? I'm searching of the particular ID. And if suppose I don't have any indexes, let me give the reference of second table. I don't have any primary key, I don't have indexes. So if I run this query and let me run how much time it will take run, it taken approximately 0.003 second, right? Millisecond is not taken in millisecond as well. So suppose I don't have any keys. Let me run the second query without without indexes. So you can see first of all it taken how much time it taken approximate 11 millisecond, right? Correct. For searching one record it taken that much of time compared the indexes. Now if you see how much number of record it readed, right? So you can see estimated number of rows to be read is 1 million rows because I have 1 million rows in the table. Then this SQL engine go each row and search, do we have this ID as this, right? Because we searching one particular ID and it taken 1 million rows, it go each rows to search. Because of that, it's taken that much of time. That's the problem statement. Let me cover one more point how it works, right? Let me run that statement. So, how it works? Take example. Suppose I have 1200 rows. Take example of employee table. I have 1200 employee IDs, right? Now, how it works? List one is you can see the last node is a data row. First index row is a what we say a root node, and suppose we have many indexes here like index rows. It is a intermediate rows, indexes rows. So now SQL engine, suppose once you create the index on the particular table, it will sort your data on particular manner, right? I mentioned, right? Data would be sorted. That's a major rule of indexes. Now, suppose we have 1200 rows and I want to search row number 1120. Okay, you are able to capture that. So now how SQL engine runs, it will go to index row and it is find the B tree means what is shortest path to find a data row, right? So it go to right because we have 401 to 800 data, 1200 data to right side, right? So it go to SQL index row decided to go into right, and once you go to right, it will again sorted into intermediate index rows. So it will go to that second index, intermediate root node, right? It will find out we have two rows, 401 to 800, and more than 800 to 1001 to 1200 in that row, right? 108 to 1200, it will is to half and half, correct? So it go to right, and it will go this side, and again once it get that, it will again split it out, 800 to 1000, and 101 to 1200. So it will find the data on that manner. So because of that, cluster index, because data is sorted, and cluster index decide which part and how, what the shortest distance to find the particular data row. Okay, you will to trigger that. Okay, that's a part of our indexes. Okay, so this is part of cluster index. So let me go to the practicality of data indexes. So let me create one table for you, and you will understand. Okay, so I have created one table index here. Okay, I have defined primary key, right, for ID column. Let me refresh the data because I recently created the data, so I need to refresh it. Let me show the property of the table. Now let me go to column. I can see primary key has been defined and not null values there, and index being created, correct? Now I'm going to insert that data. You can see the ID is not sorted while inserting the data is 31452, right? This is not sorted. So what do you think? Once I insert those data, but I have primary key and I also have indexes, so how data being inserted on particular, because I have clustered on the ID column, right? So it will sort the data based on your data values, and it will done by SQL engine itself. We are not going to that. So let me run that script and you will get understand. Correct? So let me run it. So you can see I inserted 3 first, but 3 is not my first row. You able to understand? So SQL is sorted your data because you defined primary key and cluster index in ID column. It gets sorted because cluster index knows this column have defined as the indexes, and we have to sort in particular manner. Correct? So it got sorted. That's why we get the data, and index is associated with particular ID. It won't go to store ID in somewhere in space disk. It's just associated with particular ID column. It's sorted, and we if you want to search for, it will actually hit that. Correct? Now, if I want to see the property of indexes, how we can see? So you can see this index is clustered, unique because we have unique values over there, and we have a primary key. And index is all about uniqueness, correct? That's why we have a primary key. I hope you understand that part, correct? Now, the definition of index, I always show one table only have one in cluster index. That's the key rule of indexes. So please keep in mind only one cluster index will be applied in one table. Instead, we can have multiple column on one cluster index. Okay, what do we mean by that? Suppose I have a cluster index on based on that. Right now, I have a cluster index on. Let me see the property of indexes. If you see, I have index uniqueness here. I have ID and it's ascending order, right? This is a property of indexes. Now, how I delete it, how I drop it, correct? So let me try to drop that indexes. What do you think is allow here? Because we have index and is associated with primary key, just like a foreign key. If you understand the primary key, foreign key integrity, same way, if you have a primary key, you cannot delete indexes like that because its primary cluster index is is a property to uniqueness of the data, correct? Let me run that. What do you think? Is not run, right? Because we have a primary key is just associated with the cluster indexes, correct? That's why it's not how we delete that then. We have to go to particular property and we have to make it delete. Okay, and that way your, let me refresh it, let me see the property now. You can see the primary key constant has gone, correct? Now we have a data, correct? Let me run. Do we have data? Correct, we have data. Now this data sorted is fine. Suppose I have created this cluster index based on two columns, means I want to sort this as a descending order and salary as ascending order. Let me run the query. Let me refresh it. Now let me we'll see the property has been changed, correct? Let me see the property. Now these have one index key with two columns based on that. One is descending, one is ascending, and this is not a uniqueness now. Correct? Correct. Both and two, it can be unique, but it is different. Let me run the data. Do you think that the ID column be sorted or not? Because we have changed the cluster index property, it has to change based on two columns now. And so you can see ID column is not sorted because it's not a cluster index. No, cluster index based on two now. So now male is sorted by male. As I mentioned, is a descending order, means alphabetically sorted. In in male, we have three salary, and once we male got sorted, then salary has to sort it on ascending order, right? Means minimum value minimum salary come first, and later salary come later, right? Next one. So it's sorted within this group. Then female will sort in that group. That's a property of this index, correct? So we can have the summary of this cluster index is cluster index is associated with the table on particular ID and is sorted. Because of that, data retrieval faster. We can also have cluster with multiple columns, means composite cluster index we can say. So we can have that, but data being sorted on multiple columns. Correct? You understand the concept of cluster index? Yeah, nice. Now let me think about non-cluster index. So non-cluster index, let me drop this index first. Okay. So let me assume that we have a data here, correct? And I want to let me run the query. Any other plan? Okay. Let's take a big table here on this table employee one. Okay. I'm taking example. You can see the statement here. Let and it's saying that for the better performance you have to create a non-cluster index. Let me take a statement of indexes. Okay. And let me okay. Now I want to give name, so let me give the name of it. I want a index on which name? I want a name on name column. Let me take table name and name column. I want a table employee ID, and I will give a name as a name column. Okay, so let me give a name column. Okay, uh, okay. Now let me give run the query and get a particular one name to sort it out. I'll want to search this name only. I want to search this particular ID. So result came correct. Same ID I have taken. Let me take a live statics. How what is it? And you can see on the cluster in cluster I can see only one in cluster index. Now here I can see index seek is a non-cluster. You can see the top and how much record is read it only one. And we have a lookup here, RID lookup, right? You can see the heap tree has been applied, right? So this is also one lookup. So how it runs? Let me explain on brief. So non-cluster index is it will hold the name column and it stores somewhere in the disk with the row numbers. You able to understand? Suppose we have a column name result. We have a name column. This column because we have created the non-clustering on the name, correct? And it will stores on the disk. It's not associated with the name. It stores somewhere and it capture a row ID. Means once you're able to run this query, it goes to table. okay, on the disk, on the index side, not in it not playing in here. It go to index store location, and in the name it search for this ID, and this ID, row ID, join here in the main table. Okay, so you will get the data like that. Let me see the property here, how it works. So let me explain here in the live statistics. So here it will seek the index like a cluster index. It also work as a non-cluster index. It go to the disk location, find the row ID for your search material, and then it will do the inner join. You can see nested loop inner join here. It do the join here. It join with the main table, and it find the record for you, and return the result, means correct. And the time, you can see now time got reduced, right, searching the particular object. But still, in non-cluster index it taken a 0.03 second, and here it taken 0.006 second, means still it is not performing as a cluster index, correct. It, because it taken time to go to disk space, search the your strings, name string, and revert back with row ID on your main table, correct. So this is a non-cluster index. So the majorly people ask what is the major difference between cluster and non-cluster index. So you clearly understand why we use index. So first difference would be cluster index, only we have only one cluster index on one table, okay, but we can have many non-cluster index in one particular table, right. This is the first difference. Now cluster index associate with same id column where you have created a cluster index, but non-cluster index take a different disk space and store the index on the on some other location, correct. Just like we have a dictionary, in the end of the dictionary we have alphabetical solution, and you find particular word, and you have to go into your main data set, right. That's why it works on the non-cluster indexes, correct. Let me go to the slide again and give you the differences. So difference is, we can have only one cluster index per table, whereas we can have more than one non-cluster indexes. Cluster index is a faster, because as I said, right, finding a one row it taken 0.03 second, but finding the non-cluster key it taken 0.06 second, right. You understood that, you correlate on the what we saw. And third difference is, cluster index determine the storage order of the row in the table, right. Cluster index, as I said, right, once we create a cluster index it gets sorted on particular manner, right. So is store the order of rows of the table, but hence doesn't require additional disk space, because I mentioned it associate with the particular id, right. But non-cluster index, it have a separate disk space from the table, it requires additional space. That's why we tell them the difference on that. First, we can say it's a per table we can have one indexes cluster index. Second, we have faster, right, compare the non-cluster index, and it just sort in the table itself. It won't take a additional space. Instead of that, non-cluster indexes, we can have more than non-cluster indexes. We can have we store the data on somewhere in the disk, and it less faster than the indexes. So this is for now. We have discussed about all the detail about indexes, why we use, what type of indexes we have. We also have many type of indexes like non-cluster index. We have unique indexes. We have XML indexes. We have spectacle indexes. There, but it's not being used this much, right? Yeah, that's for now. Thank you for watching. Please subscribe the channel, and we can get a more motivational video or SQL interview purpose. Thank you for watching. As per the continuous improvement, I have taken two comment for my improvement. First, I need to discuss my content in English and Hindi language both, where I can cover the both audience English and Hindi for SQL interview purpose. Secondly, I have made some changes on my camera, because my previous session, I my camera was bit broader, so I make adjustment on little bit on that, so you can see all the SSMS and slider content properly. Yeah, that's all. Thank you.